So in this lecture, we're going to examine inelastic collisions. But before we get into those, let's recall what an elastic collision is. In an elastic collision, two important things happen. Firstly, the kinetic energy of the system is conserved. It stays the same. And we get the following important equation, which basically states that the initial kinetic energy of the system of mass 1 and mass 2 is equal to the final kinetic energy of the system of mass 1 and mass 2. And this important idea comes from the fact that whenever we discuss elastic collisions, we're only talking about conservative forces. Non-conservative forces such as friction do not exist in inelastic collisions, and that means our mechanical energy, and more specifically the kinetic energy, stays the same. It remains constant. Likewise, momentum is also conserved when we talk about elastic collisions. And so we get the following important formula that tells us our initial momentum of the system of mass 1 and mass 2 is equal to the final momentum of our system of object 1, object 2 after our collision occurs. So these guys are before our collision occurs, and these guys are after our collision occurs. And so our kinetic energy before and after are equal, and our momentum before and after are also equal. So now let's look at inelastic collisions. So these are collisions in which kinetic energy is not conserved. So, unlike elastic collisions where kinetic energy is conserved, whenever we talk about inelastic collisions, kinetic energy is not conserved. And that means that kinetic energy must be transformed into some other form of energy, like, for example, thermal energy or potential energy. Now, momentum, however, is still conserved. So, whenever we talk about inelastic collisions, we cannot use this formula for kinetic energy, but we could use this formula for the momentum. Now, examples of inelastic collisions are simply most macroscale objects because they collide inelastically. Examples are two moving cars. Now, there's also something called completely inelastic collision. And a completely inelastic collisions are those collisions in which the two colliding objects stick together. For example, suppose I have this marker that is stationary and this marker that is moving with some velocity. Well, when this marker collides with this marker, they will stick together and move on together. So before the collision, they were individual objects, but after collision, they formed one system with one mass, and this is known as a completely inelastic collision. So other examples include, once again, two train cars going on the same railroad and colliding and moving off together. Now, let's talk about something known as reverse inelastic collisions, which are basically explosions. So basically what we just said is that two individual objects collide to form one object. But explosions are the reverse. They're basically one object that explodes via some reaction and then forces these two objects or this object to crack in half, separate, forming two individuals, two different masses, M1 and M2. So one ball of mass explodes to form two different masses, each moving with velocity 1 and velocity 2. Another example of reverse inelastic collisions are radioactive decay, and we'll talk about that in another lecture.